All right, CNT120, Chapter 2, we're going to go over some infrastructure and documentation. First thing we need to remember is we talked about in Chapter 1 having a network. So at your home, and actually we mentioned that, you know, the router that you have at home, the Linksys Belkin Netgear router that you have at home, is really a network in a box. So that's kind of why I drew this box here and showed you the pieces that are inside. So your home network is really contained in this whole one little box here. And all the devices in your house either connect to it physically through a patch cable or wirelessly. If you're like our house, we actually have PlayStation and Switch connected and one desktop connected to our homeowner router there, and everything else is wireless. All the phones, all the laptops and tablets and those sort of things are connected wirelessly. So when we deal with that at home, we have a couple patch cables that plug our devices into our homeowner router, which again, remember, is really a network in a box. So at home, we have a couple patch cables to deal with connections. When we move to think about maybe a school you went to or a business that you go to, you have hundreds and sometimes thousands of computer connections to connect up. If we use the same method at a school or a business where we literally just have patch cables plugging into the, into the network, if you will, there would be unorganized patch cables everywhere. So in a place like a school or a business, we can't use the method we do at home. It's not work. It's not feasible. It does not work. It's not feasible, especially for organization, managing, hooking, unhooking, or troubleshooting. So in a business or a commercial environment, we deal with networking a little bit differently. Well, before we tackle that, let me throw this idea out. In your home, how do you deal with electrical power? Do you have extension cords running everywhere to plug your toaster in, to plug your TV in, to plug your drill in, to plug your, fans or things like that? Do you have extension cords running through the house, down the stairs, and into the basement where the electrical box is from the electric company? Because what we see here is we see a picture of a house, and this is the line that, here's the electric line coming from the telephone pole, and it comes into your house, usually through a meter, and into a circuit breaker box, usually in the basement. Some people live in neighborhoods where there's wiring underground, so it would come in underground to a meter and then into the electrical box in the basement, so to speak. So do we have all of our devices in our house plugged into extension cords and running down the stairs to this electrical box? No, that would be a little bit insane. What we actually have is we have a structure of electrical outlets strategically placed around the house, and all this wiring is in the walls, so it's protected, and that allows us to, as I joke, take the toaster and plug it in the kitchen, or unplug it from the kitchen and walk in the living room and plug it in there so I can make toast in the living room, or unplug it there and walk it upstairs and plug it in my bedroom so I can make toast in my bedroom. I have electrical outlets strategically placed around the house that I can unplug and plug from power my devices very easily. And all of those outlets come to the basement to a breaker box, and that breaker box is usually labeled pretty well to say, the breaker number 2 is the outlet in the bedroom, breaker number 3 is the outlet in the hallway, breaker number 4 is the outlet in the bed, the living room. So we can connect and disconnect from power and turn power on and off as we need in various parts of the house. That's how we deal with electrical power in the house. If we apply that same concept to data in a building, that is how data is handled in a commercial building, like a school or a business. We do the same thing. There is a structure of cabling to get data outlets strategically placed around the building, so we can plug our computer in, unplug it, or move it, across the room and plug it into an outlet on the other wall. And all of these outlets are labeled and numbered and come back to a closet, so they're all organized. And in the closet, we can connect and disconnect those data drops around the building as we need. We handle data in a commercial building very much like we handle electricity in our house. Same kind of philosophy. The data method we use in our house with a couple patch cables behind the TV works with a couple devices. But when I'm dealing with 100 devices in a business, I need to use the same method that we use for like power in our house. There's a structure in place that I can plug and unplug as I need. So really this chapter is all about that structure and then documenting and maintaining this, if you will. That's really what this is about. So let's dig in a little bit further now. This structure actually is made up of a couple pieces. There's a data outlet on the wall that we can plug and unplug our computers and devices, desktops and laptops and, devices in our network. We can plug and unplug. This horizontal cabling, this blue wire, this horizontal cabling is usually installed in the walls, goes up above the ceiling, down the hallways, and then into a network closet, a data closet, and that horizontal cabling gets terminated to a patch panel. And that patch panel, think of that almost like a circuit breaker box. That patch panel allows all those terminations to come to one point. We can label them, and we can connect and disconnect as we need. And then we have another patch cable here to connect that data drop to a switch as we need it. Oh, I can plug that in for you and get you on the network, or, you're done with it there. I'm going to unplug that and use that switch port for something else, for another device. This is that structure. And if we have a multi-floor building, that structure gets repeated for the first floor and the second floor, and then we connect the floors together with typically fiber optic cable. This would be backbone cabling between the switches, typically fiber optic cable. That's typically what gets used for bandwidth as well as distance. So this structure gets repeated for floor 1, floor 2, floor 3, floor 4, floor 5. Or if I have a building with multiple wings, think about maybe a school you went to, that was the science hallway, that was the math hallway, that was the English hallway. There might be a closet in each of those wings, and we're going to connect them together the same way. So they might all be on the same floor, but they're spread out, and we would do the same structure in, the math wing, the science wing, and the English wing, and then connect them together with backbone cabling. This is all defined by the ANSI TIA 568 Commercial Building Wiring Standard. This was developed over time by lots of manufacturers, having input on, if we do it this way, things should connect up and work. All of our data connections should connect up and work. It doesn't matter what your computer is, doesn't matter what your printer is, doesn't matter what your phone is. If we do it this way, things should connect up and work. And this is better known as structured cabling. It describes basically the best way to install it, that things should work. And it really is based on that our networks are using, basically a star topology like Ethernet network. That's what it's based on. Over the years, there have been different iterations of this standard. Starting back in 91, there was the initial 568 standard. Then there was an A revision in 95, B revision in 2001, C revision in 2009, and the current D revision was put in 2015. That's the current revision, saying, again, do it this way. And these upgrades over time had to deal with, technology changes, bandwidth changes, that sort of thing. If I look at the standard a little closer, I find out it's broken into a couple pieces. There's the 568.0D that talks about general telecommunications, how we do the cabling in general. 1D is about in a commercial building, how do we do it? So not really so much your house, but in a commercial building, like I said, a school or an office building. The 2D talks about twisted pair. All the things about twisted pair, categories, terminations, distances, testing of, etc. And then our 3D standard talks about optical fiber. Again, the same kind of thing. Types of fiber, connections, terminations, that sort of thing. We mention those because that would give you an idea where to look if you have questions on distance, termination, etc. All right, so let's start working into a building. And the way this chapter is laid out, they're kind of working from the the ISP into our building. So it's kind of a logical flow to it. So we'll get through part way, we'll stop, and then I'll continue on the next podcast. So the first area they're going to talk about is the entrance facility and the Demarc. So my entrance facility is the location where, usually like my ISP or my internet connection is coming into that building. And that would be it's kind of like the main closet of this building. That's what it usually is going to be. Here's the entrance facility in this building. And that ends up usually being my main data closet. Main distribution frame is what it's going to be called. And the other thing they mention here is Demarc. The Demarc is the device that marks where the ISP responsibility ends and your responsibility begins. If you're talking about your house, whether you have Comcast, Verizon, whoever it is, usually the box that they put in your house, sometimes it's on the wall of your house or the wall of your basement, that device, usually like half of it is theirs, the other half is yours. And they're like, okay, well, if it's on this half, it's our responsibility. If it's on the other half or inside your house, it's your responsibility. The same is true for a business. That Demarc, it marks where the ISP provider responsibility ends and yours begins. So in here, where that entrance facility is usually a Demarc device. Well, I use lots of pictures. Here's another picture of a building showing, the entrance facility coming into the main closet on a 2-floor building. Here's a 3-floor building coming into here. That's my entrance facility. Then here's another one showing the main closet down here in the corner. That's the entrance facility. As I look here, here will be 2 examples of a Demarc. This is a Fios box, and essentially from their cabling coming to here is theirs, and then anything leaving this box going into my house is my responsibility. And here will be another one here. This is I think the picture they have in the book for you, showing you the ISP's fiber end here, and then the customer's Ethernet network begins here. So it's kind of like this device is marking where their responsibility ends and yours begins. Second stop on the tour is the MDF, the main distribution frame. That's your main closet. That is really the main closet of the building. That usually will have a lot of your devices. It might even have some servers in, your firewall, your router, that sort of thing. The main device is connecting your network. There's typically only one for building, and this typically, as we show here, holds all the main pieces of equipment. So in their example here, here's the main closet. That main closet is the main distribution frame for the building. In this example here, this main closet down here. This multi-floor building, this main closet down here. They're even showing some equipment back there. Here, main closet here. There's might actually be racks of routers and switches and firewalls and servers and things in here. Here might be a main distribution frame. Lots of switches and patch panels, but there also is routers and other devices down here for the facility. Here's a main server room. This most likely is the main distribution frame for the building. Here might be another one as well. We have some phone equipment in here, but we also have some main switches for the building too. Here's another one showing, here's a lot of your electrical power for the building and a lot of your data racks and server racks and things over here. Here's another one showing a number of racks in a main closet. So that's your main distribution frame, the main data closet in your building. Well, I might also have a secondary closet, or I might also have a data room. This might just be where my network equipment is. So I might actually have just a separate closet with some equipment in, or this might be some of my secondary closets in my building. And I might just have a rack of patch panels and switches, especially if my floor and my building is large. I might spread some of my equipment out. They can be as small as this, though, too. I might have a secondary data room to service maybe a large lab room, and this is the equipment that I have there. So this will have maybe some patch panels and switches, maybe a little bit of other equipment with it as well. In these, I typically have some equipment like racks and patch panels. I'm going to break some of that out in the next podcast for you.